Here is another example using z-scores. In this example we have the birth weight of children in an Indian village is normally distributed with this mean and this standard deviation. And the first question is, what proportion of the village children weigh less than this much? Now because this is less than the mean, you're going to expect that our answer will be under 50%. But to see exactly what percentage it's going to be, we need to use z-scores. So as before, you might find it helpful to think of a distribution of birth weights. Oh no, that's not going to do. Bit more room. So this is birth weights. From low to high, and so there'll be a mean somewhere here, and fewer people, or relatively few children with much less than that. Lots around the mean. Yeah, and like that. Should carry on forever. Well, in theory. So that's the mean. And as before, we want to look in this description of the situation and find which numbers are which. So the mean is this thing up here. That's the mean, written as mu. That's the standard deviation, which gives us how spread out these values are. So how much difference is there from child to child in their birth weights? So the bigger that number is, the more spread out they are. That's standard deviation. And this number here, this is the level we're particularly interested in. This is our cut-off level. We want to find out how many people are below that. In other kind of problems, you might want to work out how many people are above it, but here we want to know how many are below that, and that's usually just referred to as x or some letter like that. And that's all the information we need, I think. So we can label this on here as 2820. Let's go back to the original colour. And the cut-off point x is 2750. That's x. And to see what we want to find out, well, we want to find out what proportion of the children weigh less than that. So we want to know if the whole area under there is 100%, that's all the village children, obviously most of them here around the mean, a few bigger babies and a few smaller ones. We want to know what percentage of babies are in this area here. So that's the percentage we'd like to know. And because this is normal, we can just look it up in normal tables or on a computer using Excel, as long as we know the z-score, which is the number of standard deviations we are away from the mean. So we need to convert that into a z-score. And, well, we've got a formula for z-scores, which is z is the number you're interested in, subtract the mean over the standard deviation. Because that's the actual distance from here to here, which is going to be 70. So you're 70 below the mean, and divided by the number of standard deviations. Standard deviation is 96, so it's going to be slightly less than 1. Not quite 1 standard deviation. So we've got 2750 minus 2820. That's that distance. Then divide it by standard deviation, see how many of these it is. So that's 70 over 96. So it's not less than 1, it's 0 point something. Let's get your calculator out, or your phone, or whatever, and work out the 70 divided by 96. 7291666666. that dot on the 6, if you haven't seen it since school, means it carries on forever. 7921.66666. Now he wants to know for a z-score of that, in other words, this many standard deviations above the mean, what proportion is less than that? Oh, I've forgotten something vital here. This is a minus. So this is minus. Because we're z down here is going to be minus. So this is how many above the mean, but we're below the mean. So this minus this gives you a negative number. It's negative because you're below the mean. Now let's just see if we can get the answer to this from a spreadsheet. Now before I've shown you this one, which has got it built in, but I suppose you might just start with a blank spreadsheet, and you want to know for this number, which I've forgotten already, 729166, what proportion of the normal distribution is below that? It's negative. So the form we can type in is let's just see if it's going to be happy on the minus numbers. Oh, I've got an S. Norms dist. Yeah, 0.23. So there's the formula. Norms dist, put in this number 7291666, and it gives you 0.23295. And that is exactly the same as 3.2. Let's make it approximate then. 295. Okay, we'll run it on at 5, which is approximately equal to T3.3. Because if you round this one up to 0 to, if you round this one up, then that one's going to have to get rounded up. So 23.3 to 1 decimal place. Below. So we've got 23.295, or 23.3% of babies are below that birth weight. Right, now let's have a quick look at part 2. Now part 2, is a slight variation because here we're dealing with the same situation, same distribution. So we've got the mean of 2820. Mu. But here we're going to put this NGO they want to put some level in here, and they're going to give all these children here a supplement. But instead of telling you what this level is going to be and asking what percentage is going to be, the NGO have decided they want to give supplements to the lowest 10%. So the question is here, what should that be? That's the question. What level should we set this at? So you have 10% below it. Now, hopefully you can see that if this one now works out as 23%, so 23% below there, if we want to bring it down to 10%, this is going to have to be lower. So the answer we get is going to have to be less than this one, because we only want 10% down there. But what should it be? Well, and this is one we can look up. We can work backwards. We need to look up the z-score from tables or from Excel. So what should the z-score be so that it leaves 10%? Let's go back to the spreadsheet. Point 1, and what we put in here is the other formula. Oops, it's the inverse. Inverse 0.1. Let's put 0.1 in by hand. Minus 1.28. And then to check that, if you put this back into the thing we had just appear, this function, norms dist, norms dist, put that number back into it, then you get 0.1. So it's looking up backwards. So looking up 0.1 z-score, looking up 0.1 the proportion, the proportion that's less than the z-score has got to be 0.1. It predicts the z-score is that. If you put the z-score back in, then it says the proportion is that, so that works. So using that formula, if you know the proportion you want below it, which is 0.1 here for 10%, that tells you the z-score. So z is minus 1.28155. So this is the number of standard deviations below the mean here. Number of standard deviations below the mean. So the number we want to know, what should x be? Well, it's got to be start from 200 to start from the mean and take off this number of standard deviations. The standard deviation was 96. I'm going to give up minus 1.28155. Times 96. 123.0288. So 2696. 2697. So they should set it at 26. Just round off the nearest gram, perhaps 2697. And give supplements all below this level. All babies with birth weight below this. So set that to 2697. Give all the babies that weigh less than 2697 the supplement, and that will work out as 10% of the babies according to this calculation.